Hello! Here we are into a brand new year with a brand new start. I hope you all have been healthy and stay committed to keeping your immune systems top notch this year, too. Talking about diseases and the different immune reactions prompted by various antigens, I feel it is imperative to understand how healthcare practitioners get to know the state we are in. Identifying what has infected us is key to correct treatment. And here we land with SKA to begin a new series of learning that is understanding various techniques in immunology to identify the cause behind a disease. He does here what a hardcore researcher does best, sharing with you those key takeaways of immunological techniques from the very basics to advancements till date. Let's get in tune again and ramp up the work along with all these fundamentals available at a single click on your devices. Do share with your peers and don't forget to subscribe to keep learning together. Over to SKA.
Hello, friends. Welcome back to Immunology for Everyone. At the onset, I would like to wish you all a very happy new year, 2025. I'm sure you all had exciting Christmas and New Year parties. And let's begin once again with a new chapter in the new year 2025. I was thinking what to start in the new year, and as we all know that we have discussed about the activation of immune response whenever our body is exposed to a pathogen, and the innate immune response leads to the activation of adaptive immune response, which is driven by antigen specific T cells and antigen specific B cells. The antigen specific T cells, when get activated, they expand, they basically clonally expansion, and then they differentiate into various kinds of cells, the Th1, Th2, Th17, T follicular helper cells, T regulatory cells, depending on the cytokine milieu and the pathogen which is seen by the antigen presenting cells. And then some of these T cells, they interact with the B cells, which are antigen specific B cells. They carry the receptor on their surface, and on activation the B cells also clonally expand, and some of these cells, they differentiate into antibody forming plasma cells, and then there is a lot of antibodies are being produced. So now let us think that when there are so many people who are exposed to the pathogen, not everybody gets a disease. Some people get very mild symptoms, some people don't get even no symptoms at all, and some people they fall sick. So that means our immune response is different in different individuals. So how do we actually look at the quality of the immune response and the quantity of the immune response? So there are many amazing techniques which have been developed over the years, and they are basically used to look at the quality and the quantity of the immune response in a particular individual. Besides giving us information about the quality of immune response, which may be required for the protection, the immune parameters like the antibodies and the cytokines, they basically help in diagnosis, specific diagnosis of the infection. Because you take the example of HIV, whenever the body is exposed to HIV, the person may not show very specific symptoms, and we all know that there is a long latency period which is called the asymptomatic period, which may vary from few months to many years. Even in some individuals for 10 years they don't show any symptom. So how do we know that a person is infected with HIV? So that can be known only by doing some laboratory tests, which are to look at whether the person is have made the antibodies against the HIV. So if there are specific antibodies, they are detected by specific techniques, and the laboratory diagnosis confirms the infection of HIV, and that is how we diagnose many other diseases: typhoid, you take hepatitis B virus, hepatitis C virus, and many other. So I thought that let us start with discussing some of the amazing techniques, and we will begin with very preliminary techniques. Uh, and Let me tell you that whenever a antigen is in the soluble form, if it is mixed with the antibody in the soluble form, then the antigen antibody they interact and they bind to each other because of their specificity. And whenever the mixture is equivalent, like every antibody has got valency for binding to the antigen, like one immunoglobulin molecule will have a valency of 2, and it can bind to two antigen molecules. Similarly, there are valencies. So whenever there is a equivalent condition, then they form antigen antibody complex which gets precipitated, and that precipitate can be measured or seen and can be quantitated also. So initially, uh, if you take this in the soluble condition, then in the soluble form the precipitates are sometimes very minute, and with the naked eye you cannot appreciate it. But there are very good techniques like flometry. They basically look at the turbidometry. So turbidity, because once the precipitate is formed, the turbidity will change in the solution, and you can actually quantitate the amount of precipitate in a solution. And similarly, there is nephrometry. But there are other amazing techniques which we used to use a long time back. When I was a student, we had many good techniques which are called the immunodiffusion techniques, and that they are done in a soft agar. And in the soft agar you can mix the antibody and you can add soluble antigen and antigen antibody diffuse, and wherever they have the zone of equivalence, they will form a precipitin arc. And those techniques, immunodiffusion, there are many immunodiffusion techniques like one dimensional, two dimensional, and then single radial immunodiffusion will give you a quantitative part also. Not only that there are antigen antibody present, but what is the quantity of that. They are the single radial diffusion. And then you can also have quality of or heterogeneity of antigens, because different types of antigens or antibodies, they will form different precipitin lines, and that will give you multiple lines. And then an amazing advancement came when they added the electrophoresis with the immunodiffusion. And that electrophoresis will work when you have the soft agar which is dissolved in a particular buffer with a particular pH. And if it is an alkaline pH, the antigen, which are the proteins, they will acquire a net negative charge and they will move towards anode. Whenever the electric current is will be passed, the antigen molecules, which are proteins, they will move towards the anode, and then they will meet with the antibody. So there are many immunoelectrophoresis techniques they were developed, and among them there was simple immunoelectrophoresis, the rocket immunoelectrophoresis, the crossover immunoelectrophoresis, and then came a very amazing technique which is called the countercurrent immunoelectrophoresis. That technique basically is based on the principle of electroendosmosis. Electroendosmosis is a phenomena by which whenever the electric current is passed through a medium, then it causes ionization, and many positively charged ions are formed from the buffer, from the media, it may be agarose, and then all those positively charged, ions, they start moving towards the cathode. So the principle is that whenever you want to do counter current immunoelectrophoresis, you make a pair of wells, and in the well which is on cathode side you add the antigen, and in the well which is on the anode side you add the antibody, and then you pass the current. The antigen, being negatively charged because of the alkaline pH, will move towards anode, while the electroendosmosis, most of the ions which are moving towards the cathode, they will drag the immunoglobulin molecules, because immunoglobulin is relatively less charged as compared to other proteins. So it gets dragged towards the cathode, and then the antigen and antibody, they meet in the middle of those two wells, and they precipitate. And this technique gives you an answer within, say, about 1 hour to 1.5 hours. So otherwise immunodiffusion techniques, they take about 24 to 48 hours, well, at least 24 hours, because there is diffusion, simple diffusion. So these are all techniques which we used to do, and they are still very simple. They are very inexpensive, very reproducible, and can be done in any laboratory without the need of very sophisticated instruments in the lab, as well as even if a technical person is not that trained, he can also do all these techniques. So these are very good techniques. So uh, now what we will do is we'll try to move towards some very analytical techniques, and most amazing ones are the enzyme linked immunosorbent assay, immunofluorescence techniques, immunohistochemistry, and then going further, we will discuss many advanced techniques. So today I'll stop here because I introduced you and we have started with discussing the immunological techniques by which we can actually qualitate the immune response which is generated. So, thank you very much. Till next time, goodbye and take care.